Hi, this is Charles Anderson. I'm a chemical engineer who's been using Excel for quite a while, and I thought I'd do a couple of quick recordings to try and show some of the areas that I find really useful. What I'm going to try and talk about today is the solver, which is a component that comes with Excel but is not enabled by default. It's quite a powerful optimization tool, and I tend to use it both for optimization, where I've built a model with some inputs and I'm trying to find out how to maximize or minimize one of the outputs. So classic optimization. But I also use it for data regression and for solving equations, for example, closing a recycle loop if I've set up a mass balance in Excel. So what I'm going to look at today is regressing parameters. So, I may have some data that looks like this. I'm going to try and come up with a model to see how well it fits the data. And ultimately what I'm going to try and end up with is a best fit line through the data points. So let me run through how I would try and tackle that. First up, I'm going to sort of create that data set. It's obviously in the real world, I'd have some data that I was trying to fit. What I'm going to do here is I'm going to just try and create the data set just to show you a couple of features, the secondary features of Excel that are kind of interesting. What I'm doing here is I've set up an X range, and then I've created a series. What's nice when you create the series is you can see Excel sort of recognized me as starting to write a series, so it's filled it in as a series. If I didn't want it to do as a series, and sometimes it does it by default when you don't want it to, you can instead copy the cells. You see by copying them, it's just repeatedly done 0.1, 0.1. In this case, I did want it to fill, so I'm going to have it fill. I'm then going to, I'm looking over at my cheat sheet over here, I'm going to put in a few pieces of data for my y parameters, and I'm going to put in an equation to calculate a value of y. So just for whatever reason, I'm going to say y is equal to a plus b times x squared plus c over x over x. So it doesn't really mean anything, and obviously I've got to divide by zero error. Using that same data fill, I can double click on the dot and I can fill it in. You'll see that's got all sorts of nonsense, and the reason is I didn't fix the relative and fix references. So what I'm going to do now is I'm going to come through and I'm going to correct that. I'll hit F4 to cycle through the options. I can, of course, just put in the $sign if I want to. Oops. And then I'm going to want, just for later, I'm going to fix those guys as well. So now when I copy the cell down, you'll see it fills in each of the cells correctly. I can double check to make sure that it's pointing at the cells I want it to, so that's good. The next thing I'm going to do is I'm going to add some noise, and to do this I'm going to use the random function. The random function gives you a value of between 0 and 1. So I'm going to correct that to be between 0.5 and 5, and then I'm going to multiply it by 5 to give me a noisier set of data. So what I'm going to do then is I'm going to have a random number, which is going to be between 0 and 1. I'm going to take away the 0.5 to give me between minus 0.5 and plus 0.5, so my noise is above and below the data point, and then I'm going to multiply that by the value. And of course, once again, I forgot to do the relative numbers, so there we go. I've now got my data set for some noise between 0.5 and 5. One of the interesting things about RAND is that it's unstable. It recalculates a random number every time you do it. So to sort of stabilize my model, I'm going to copy that data. I did a Control-C, or I could do copy, and then I'm going to paste the values. So now you see I've got just fixed values. You'll notice in this top row, I've actually got the formulae still. If I want to, I can copy that back down over the data. I'm not going to do that. The last thing to do is to get my measured value. So this is then going to be equal to the actual value plus some noise. And then this is going to be the data that I'm going to fit. And then finally, I'm going to put in the formula for my fit to the y value. And in this case, what I'm going to do is I'm going to cheat. I'm going to steal the formula from there. And you can see I've taken the same form, and I'm going to try and refit the parameters. At the moment I haven't got any parameters in there, so I'll just make those all 1s just for the fun of it. Copy the value down. And then finally, as is often the case when you're fitting data, I'm going to fit the sum of the squared errors. So the squared error is going to be the measured value, is going to be the measured value minus my calculated value squared, and then slap all that down. I'm sorry, it looks like I messed up and deleted the wrong cell there. But so now I've got my sum squared, I've got my squared errors, and I'm going to sum those to give me my objective function. The thing I'm going to try and fit the sum of squared errors. So then finally, let's build that graph. I've got my x values, my measured y and my fitted y. I'm going to plot those, see what they look like. Doesn't look like a terribly good fit. I'm going to switch my data over to have a solid line and no marker. No marker. And so now I can see what it looks like. So now you can see I've got an objective function, I've got some values. If I change those values, my error will get smaller. But I can do that manually. What I'm going to do instead is use the solver. So first off, to turn the solver on, it's there in Excel, but you've got to enable it. So I come over to the File, Options, I go to the Add-ins tab, or the Add-ins area, go make sure I've got the Excel add-ins, I go to that, and then I make sure that my solver add-in is checked. Looks like I already had it turned on, so that's okay. What that does, if I then come over to the Data tab, or the Data ribbon, I should say, over at the end here, it gives me this Analyze option where I can set up the solver. So what I'm going to do is open the solver. You can see it gives me a wizard to work through. It's going to say, what's my objective function? That's the sum of the squared error. I want to minimize that, and I want to minimize it by changing these 3 values. I can put in constraints to say it's got to be greater than or less than something. I could force it to be an integer, which is sometimes useful if I'm, for example, counting how many tanks I need, that sort of thing. I can't have a half piece of equipment. I've got to have an integer number of pieces of equipment. And then I can also, by default, it forces the fitted values to be non-negative. I'm not a big fan of that, but it's useful. In terms of how I solve, I've got a straightforward nonlinear optimizer, a sort of Newton type method. There's an LP, a linear program, a simplex method rather, and there's an evolutionary method where what it does is it solves, it starts the model off from lots of different data starting points and then sees if it converges to the same solution from all those different starting points. We're just going to keep it simple though, so I'll go with my standards, and I'm not going to look at the solver options right now. Hit solve. And you can see it churns away. It's the data, the line runs through the data nicely. You can see the real parameters and the model parameters aren't too far apart. So that's all pretty good. What I can do, some of the other things I might do is if I got data from a different region. So I'm just cheating here. I'm just going to push it over a wider region. You can see that the model I've got fits pretty well down here. It's starting to diverge up in this other area. So you can see as I get new data, I might want to refit the model. And so I reopen solver, run it again, and you can see it's pulled that sum squared error down. It's running through the data points a lot more cleanly. Arguably, these parameters are closer to what they should be. So that's it. Hopefully that gives you a flavor for how to use the solver, how to set up a data regression kind of a thing. And thank you very much.